The Zoom session is being brought to you by the fractal globe snow ring B. All right. For today, we start talking about the dot product. Okay, we're actually getting to where some trigonometry is required. All right. Dot product takes two vectors, v1, v2, and w1, w2, and it's written as dv dot w, and it gives out a number. It takes in two vectors and gives out a number. It's a little odd. Usually products give back the same kind of thing they put in, but that's how the dot product works. All right, so there are two ways to define it. One in terms of the component, the rectangular components, the other in terms of lengths and angles. The one in terms of components, a more algebraic definition, is v1 w1 plus v2 w2. You multiply x components, you multiply y components, and you add the results. The more geometric definition in terms of lengths and angles is the length of v times the length of w times the cosine of the angle between them. All right, now, okay, we could go on to a proof in trigonometry why these two are identical. We'll just work from that from here. It has this dot product, it acts like a product in some ways. It has various laws which are like the rules for products. One is that it's commutative, v dot w equals w dot v, fair enough. Now, if there's a zero vector whose components are 0 by 0, and any vector dot zero vector equals the number 0. Okay. Moment. Let's check. Here's one, v dot v equals length of v squared. Now that follows from both of these rules. V dot v being length of v times length of v times cosine of the angle with itself. That angle is 0 and cosine of 0 is 1, so length of v squared. And by this definition, v dot v will be v1 times v1 plus v2 times v2. In other words, v1 squared plus v2 squared, and that's the length squared. It's also associative with scalar product. K times v dot w is k times v dot w. It's also distributive over vector sum. U dot v plus w equals u dot v plus u dot w. It's looking a lot like ordinary multiplication. Now the vector I, the vector is 0 by 1 by 0 in the x direction, dot it with itself equals 1. Its length is 1. J dot j, the unit vector is 0, 1 in the y direction, dotted with itself also equals 1. Okay, that's again, that follows straight from here because I and j both have length 1. And I dot j equals 0 because they are at right angles to each other and cosine of 90 degrees is 0. Okay. Now, if we start from this rule, v dot w equals length times cosine of the angle, and you divide by the lengths and you take an arc cosine, and the angle between the vectors is arc cosine of the dot product divided by the product of the lengths. Arc cosine of u dot v over length of u times length of v. Now, if u dot v is 0, then you get arc cosine of 0, which is 90 degrees. So these are called orthogonal. Vectors are orthogonal, meaning at right angles, if their dot product is 0. For example, I and j are at right angles and their dot product is 0. Okay, so we do some examples. Here's one vector, 2i plus j. In other words, 2 by 1. Vector w is I minus 2j, in other words, 1 by negative 2. What's the dot product? What's the angle between them? Okay, easy enough. The dot product is 2 times 1 plus 1 times negative 2. That's 2 minus 2 is 0. Okay, and the angle between them is arc cosine of 0 over the product of lengths. That'll be arc cosine of 0, which is 90 degrees. They are at right angles. They're orthogonal. Here we have v is 3i plus 4j, 3 by 4. W is minus 6i minus 8j, minus 6 by negative 8. What's their dot product? What's the angle between them? All right, have to tell. Dot product is 3 times negative 6 plus 4 times negative 8. Negative 18 minus 32 is a minus 50. Length of v, square root of 3 squared plus 4 squared. That's root of 9 plus 16, which is root 25, which is 5. In other words, the 3, 4, 5 triangle. Length of W is -6 squared plus -8 squared is root of the square root, which is root 36 plus 84, which is root 100, which is 10. Well, also the 3, 4, 5 triangle twice as big. So theta is arc cosine of the dot product, -50, or the product of the lengths, 5 times 10. That's arc cosine of -1, which means you have to go all the way around the circle to 180 degrees. These are anti-parallel. They are they're pointing in opposite directions. 3 by 4 here, -6 by -8, opposite direction and twice as long. All right. Here we have V equals I minus AJ, so it's I by -A, and W is 2I plus 3J, 2 by 3. Find a value of A that makes these two vectors orthogonal at right angles. Okay, so if they're orthogonal, then the dot product is 0. So 1 by -A dot 2 by 3 equals 0. That works out to 1 times 2 is 2. -A times 3 is -3A. 2 minus 3A is 0. Transpose and transpose. A equals 2/3. And there you have it. Now, one concept related to dot product is something called in physics called work. Work is basically force dot displacement. It's basically the amount of force exerted along a displacement. The force exerted perpendicular to the displacement does no work at all. A ball can roll along a floor and keep the same speed indefinitely, no friction. And that's because all the force is gravitational, which is into the floor at right angles to the displacement. So that work is 0. But if you're pushing the ball in the direction it's moving, that it speeds up because you were doing work to it. So if you're given a force operating on an object through a displacement d, then the work is F dot d. So here we have 3 pounds force at 60 degrees to a displacement from 0, 0 to 6, 0. What's the work? All right, you can work out the force, 3 cosine 60 by 3 sine 60 in the triangle here. And after a bit, that's 1.5 by 3 root 3 over 2 is the fourth. Displacement from 0, 0 to 6, 0. Difference of the x values is 6 minus 0. Difference of the y values is 0 minus 0 is 6 by 0. So work is F dot D, 1.5 by 3 root 3 over 2 dot 6 by 0. 1.5 times 6 is 9. 3 root 3 over 2 times 0 is 0. Add them up, you get 9. So it's 9 foot-pounds. Those are the units that are, those are units of work. Here we have my rather crude rendition of a car. Kind of looks like a like roller skate actually. And okay, it's on a slope, tilted at an 8-degree angle. The van or whatever it has, this weighs 5,300 pounds. What is the force along the pavement in that direction? What is the force into the pavement? That. Well, we draw this force triangle with side A, force along the pavement, side B, force into the pavement, 5,300 in the vertical part, and here's an angle of 8 degrees. Well, all right, we have some right angle trigonometry. A over 5,300 is sine 8 degrees, B over 1,500 is cosine 8 degrees. So A is 5,300 sine 8 degree pounds, B is 5,300 cosine 8 degree pounds. And then with a bit of calculation, that's about 737.6 pounds along the pavement. So you have to set your rates fairly strongly. And 5248.4 pounds into the pavement. So your tires, its tires should be well inflated. Okay, I believe we have